The second application of uniform circular motion, that is wave or wall of death. त्याला आपण मौत का कुवा असं सुद्धा म्हटलं जातं पहा की पहिले खेड्यामध्ये किंवा गावामध्ये यात्रा असायची आणि यात्रेमध्ये असा मौत का कुवा म्हणजे अशी एक विहीर असायची. This wall of death is nothing but it is a vertical cylinder. It acts as a vertical cylinder and this is the base of this vertical cylinder. This is the top position and this is the mid position, and the vehicle is move in inner part of that cylinder, vertical cylinder. And suppose we consider the radius of that vertical cylinder or wall of depth is r, and the vehicle is revolve inside this wall of depth or vertical cylinder, but the motion of that vehicle is horizontal, and that is also called stunt. Suppose the vehicle at point A, suppose this is the center C, and we assume that the vehicle at point A, then the different forces acting on that vehicle. First, its weight or weight of vehicle acting vertical downward. This is the first force acting on that vehicle. W is equal to mg. Now second force, that is the force of friction, between inner part of this wall and tires of vehicle. This force is denoted as Fs, or this friction is a static friction. Now the another force, that is this mass is acting, or weight of that vehicle acting vertical downward, and the force of friction between wall and tire of vehicle Fs is acting vertical upward. Now this is the Fs is the force between, or force of friction between the inner side of this wall and tire of vehicle, and this force acting vertical upward. Then in this case the role of that force of friction is to balance the weight of vehicle. Hence we can write Fs is equal to mg. Now the normal reaction, the third force, that is normal reaction acting horizontally, that is, this is the position of normal reaction, and this normal reaction acting on this vehicle is horizontally towards center C. Hence acts as centripetal force. The direction of normal reaction is toward the center C. Hence the magnitude or this force, that is normal reaction, acts as a centripetal force. Hence we can write N is equal to centripetal force CPF is equal to mv square upon r. This is the normal reaction, and this normal reaction acts as a centripetal force. Hence we can write N is equal to mv square upon r. Now also we have the force of static friction. The force of static friction, that is Fs, is equal to mu s into N, where this mu s is the coefficient of static friction and N is the normal. Therefore we can write or rearrange the equation. Fs is equal to mu s into N. Now we use the value of this N. Therefore Fs is equal to mu s into mv square upon r. We get Fs is equal to mu s mv square upon r. Now from this equation Fs is equal to mg. Therefore mg is equal to mu s mv square upon r. The m is the mass of vehicle, the cancel in both sides. Therefore g is equal to mu s v square upon r. Now you find out which speed or which velocity of that vehicle. This vehicle is moved in circular orbit inside this cylindrical wall or wall of death from bottom point to top point or top point to bottom point. Then this velocity is v square is equal to or R into Z divided by mu S, or V is equal to under root RG divided by mu S. This is the minimum velocity of that vehicle, or when this vehicle attain the velocity V is equal to under root RG divided by mu S, then that vehicle is revolved inside this cylindrical and it moved top to bottom. This is the minimum velocity or velocity of that vehicle, where R means the radius of that cylindrical surface, or this radius of that wall of depth. G is acceleration due to gravity. Mu S is nothing but the coefficient of static friction. Now we discuss the another application of uniform circular motion, that is application number 3. Vehicle on a banked road. Vehicle on a banked road. To bank means to curve. If the road is as like a curve or zigzag, then what is the speed of that vehicle when that vehicle is driven safely in this curved bank road? Now if you consider, suppose this is the road surface, horizontally road surface, and this road is curved or banked with angle or in angle theta, where this theta is called angle of banking. The angle of banking means there is small elevation of inner and outer side of road, and this is given as theta, or theta means angle of banking of this curved road. And we consider the vehicle is moving around this curved road. Now in such situation there is some forces acting on that vehicle. Let M be the mass of vehicle and small r be the radius of banked road or curved road. Now the different forces acting on that vehicle. The first force acting on that vehicle is its weight acting vertical downward. And the another force, it is called normal reaction acting vertical upward. The different forces acting on that vehicle when this vehicle is over the banked road, the first, its weight acting vertical W is equal to mg. And second, normal reaction N acting vertically upward. But this normal reaction resolve or separate into two component. The first component is acting vertical, that is called N cos theta. The first component, the normal reaction resolve into two components or separate into two components. The first component acting vertical upward, that is called N cos theta, and second component acting horizontally, that is called N sin theta. That component is called N sin theta. But this component is towards the center of that banked rod. Now, from this the vertical component N cos theta balance the weight of this car or vehicle. Hence we can write N cos theta is equal to mg. The value of that N cos theta is very similar to weight of car or vehicle. Hence the role of N cos theta is to balance the weight of car. Hence we can write N cos theta is equal to mg. Now the second component, that is horizontal component, N sin theta, it acts as a centripetal force. Hence this component N sin theta is equal to centripetal force or is equal to mv square upon r. Now, from these two equations, N sin theta divided by N cos theta is equal to mv square upon r into mg. N cancel, sin upon cos, tan theta is equal to v square upon r. Again, the cancel, then we get tan theta is equal to v square upon rg, or theta is equal to tan inverse v square upon r. Theta is equal to tan inverse v square upon rg, where this theta is called angle of banking. And using this formula, we calculate the angle of banking, where p means velocity of that vehicle when this vehicle move over the banked road or curved road. R is radius of this circular or curved banked road, and g is acceleration due to gravity. Also, we find out the safety speed of the vehicle when the vehicle is moved over this curved road. Therefore, from this equation, v square is equal to rg into tan theta, or v, s means safely speed, V is equal to or Vs is equal to Rg tan theta. Using this equation, Vs is equal to under root Rg tan theta. This is the safely speed of any vehicle when this vehicle is moved over the banked road or curved road. This is not a minimum and maximum speed of vehicle. This Vs is not minimum or maximum speed or velocity of that vehicle. Vs is the safely speed of that vehicle when this vehicle is moved on the banked road. This is the third application of uniform circular motion.